What would happen if the waste of 1.4 billion people became the raw material for a $13 billion industry? In India, waste does not stay on the city's edge. It moves through crowded markets, darkens canals, and rises into giant landfill mountains that receive more than 150,000 tons of municipal waste every day. But within that very crisis, India has begun to see a forgotten resource. Bagasse, after leaving sugar mills, is pressed into biodegradable tableware. The types of plastic that have almost lost their commercial value are brought into mixing plants, wrapped around hot stones, and turned into a layer of material beneath the road surface. Meanwhile, graveyards of old tires are awakened inside pyrolysis furnaces, reborn as recovered oil, gas, and carbon black. So how is India operating this giant recycling machine? Let's explore with Mandarin Tech. As the most populous country in the world, India generates a massive stream of waste every day, placing heavy pressure on an infrastructure system that is already overloaded. As the economy continues to grow, consumption rises, and people keep moving into major cities, waste is no longer a problem that can be solved with a few separate policies. Amid this pressure, Dharavi, in the heart of Mumbai, has become a distinctive cross-section of modern India. Often seen through images of poverty, overcrowding, and chaos, this place is actually operating like a quiet recycling machine. Inside its dense alleyways, what the city throws away is collected and processed before being brought back into the market. What makes this story special is that, right in the middle of this immense pressure, India has also become a breeding ground for many bold recycling models. But not all waste finds its way back to the market as it does in Dharavi. In Delhi, Palswa is an unforgettable image of that reality. Covering about 70 acres and rising more than 60 meters high, this landfill is almost an artificial mountain built from what the city has thrown away, as it is compressed over many years. Leftover food and organic matter decompose in oxygen-poor conditions, forming a giant body that quietly heats up from within. Landfill gas often contains about 50% methane, turning this place into a source of emissions that continues to live, leak, and push pollution back into the city's sky. Right on top of that toxic body, thousands of people still make a living every day. They search through the waste for plastic, metal, and anything else that can still be sold in exchange for about 200 to 300 rupees, equivalent to $3 to $4 US. What is haunting is not only that small amount of money, but the way people exist among the mountain of trash. Bare hands, bare feet, no masks, no protective gear, bending down amid dust, smoke, foul smells, and scattered layers of waste. A study in the Lancet Planetary Health shows that long-term exposure to air pollution contributes to about 1.5 million deaths in India each year. India is not only a major sugar-consuming country, but also one of the most important sugarcane centers in the world. Each production season, factories across the country crush sugarcane to produce sugar, molasses, and ethanol. But behind that sweet industry is a massive amount of byproduct, bagasse, with output that can reach about 100 million tons each year. At that scale, if bagasse is piled up for too long, this damp fiber takes up space, ferments, produces odors, and quickly becomes a burden for both the factory and the surrounding environment. That is why in Uttar Pradesh, Chuck has chosen a different path, keeping that fiber, cleaning it, molding it, and turning it into biodegradable bowls, plates, and food trays. During the peak harvest season, about 100 trucks of bagasse can arrive at the factory every day. Each truck takes up to 2 hours to unload. The bagasse is kept in damp piles, as if it is being kept breathing before entering the production line. From here, the raw fiber begins to be cleaned. This step helps separate the sticky layer left behind after the sugar crushing process, making the plant fiber cleaner. After cooking, the mixture is washed again to remove any remaining chemicals. From a mass of raw fiber, the bagasse has now turned into a damp fibrous pulp, soft enough to go into the molds. Then the shaping process begins. The mixture is put into pressing machines, compressed tightly, and drained of water to form bowls, plates, and food trays with clear shapes, strong enough to be used with food. After leaving the molds, each product is inspected, counted, packaged, and sent to the market. The factory can produce about 1 million products a day, a number that shows Bagasse is no longer just a byproduct on the margins of sugar mills, but has entered industrial-scale production. But the product only truly has meaning when it is handled properly after use. If composted under suitable conditions, a Bagasse tray can decompose within about 90 to 180 days. But if it is thrown into a landfill, it can still become trapped in an overloaded waste system. In 2019, the world generated about 353 million tons of plastic waste, but after the entire process of collection and treatment, only about 9% was actually recycled. The rest ended up in landfills, drifted into canals and waterways, gradually broke down into smaller pieces, and could remain in the environment for hundreds of years. Each year, India generates more than 4.1 million tons of plastic waste, and the hardest part to handle is often thin, lightweight, and low-value plastic. These materials are not attractive enough for many collection facilities, are not uniform enough to be recycled easily, yet appear everywhere in urban life. It is this hard-to-control group of waste that has led the country to choose another path, pulling part of its plastic waste into the road surface. First, the plastic must be separated from the mixed waste stream, have the dirty parts removed, be cleaned, dried, and then shredded into small pieces. This is not only a preparation step, but also a way to turn scattered, contaminated waste into a material stable enough to enter the road building process. At the mixing plant, crushed stone is heated to about 170 degrees Celsius. When the shredded plastic is added, the heat softens it and makes it cling to the surface of each stone like a thin coating. Then bitumen is added to lock the entire mixture together. From plastic pieces that have almost no commercial value left, they become part of the asphalt material, buried deep inside the road structure. From there, the hot mixture is transported to the construction site, spread in layers, and compacted by road rollers. As it cools, the road surface gradually hardens, keeping the plastic fragments inside instead of allowing them to keep wandering through the environment. By July 2025, India had completed about 43,700 kilometers of rural roads using waste plastic technology under the PMGIC program. This is no longer a small experiment, but has become part of real infrastructure, where millions of people pass every day. Not only in cities or factories, India's waste problem also rises in smoke from its fields, where straw and agricultural residues after the harvest season have long become a difficult burden to handle. For many farmers, they are too bulky, difficult to collect, and slow down the next crop cycle. So the fastest way to deal with them for many years has been to burn them directly in the fields. In just a few hours, the ground is cleared, but the smoke spreads through villages and highways, contributing to the thickening toxic smog in northern India. Instead of being burned in the fields, straw is collected, taken to processing sites, and then dried in the sun or by machines to reduce its moisture. If it is still too wet, the straw will be difficult to grind and press, and it will produce weak fuel pellets that break easily and burn poorly. When it reaches the right level of dryness, the straw is cut short, ground into smaller pieces, and cleaned of soil, sand, binding strings, metal, and other impurities mixed in during collection. From long, light, and tangled stalks, the material gradually becomes a drier, cleaner, and more uniform fiber. After that, this fiber is fed into a pellet press. Under high pressure, and the heat created by friction, the straw is compressed through a steel die, forming small, solid fuel pellets, usually less than 25 millimeters in diameter and less than 50 millimeters in length. When they meet the required standard, they can have a heating value of about 3,500 kilocalories per kilogram, enough to be used in boilers, drying plants, or co-fired with coal at thermal power plants. India is one of the world's major textile and garment centers. This also means a massive amount of waste is created right from the factories. Leftover fabric cuttings, defective fibers, unsold inventory, substandard clothing, and bundles of old clothes collected from many places. India's pre-consumer textile waste alone is estimated at about 1.85 million tons each year. And when this stream of material needs a place to return to the market, one name is often mentioned: Panipat. When large bundles are brought into the workshops, Workers have to sort them by material, color, and condition. Parts that are too old have their zippers, buttons, labels, and metal details removed before entering the shredding machine. The cutting machine grinds the fabric pieces into small fibers. Then the carding system continues to loosen them, breaking apart the tightly woven layers of fabric and turning them back into a soft mass of fiber. From there, the workshops begin blending. Recycled fiber is often mixed with a portion of new fiber to increase durability. Once mixed in the right ratio, the recycled fibers do not go directly into production. First, they are pressed into large blocks so they can be controlled more easily and moved into the next stage of the production line. From these fiber blocks, machines continue to loosen, card, and draw them into long, coarse fiber strands, like a layer of cotton gathered into a continuous flow. This is an important step, because if the fibers are uneven, the finished yarn will easily break, become fuzzy, and be difficult to use in weaving machines. The coarse fiber strands are then transferred to the spinning system. Here, the machines both stretch and lightly twist them so the short fibers can cling together, forming stronger yarn. Once the yarn reaches the required thinness, it is wound into large thread rolls, ready to move into weaving or sewing. From there, the recycled material can become blankets, carpets, lining fabric, soundproofing layers, cloth bags, or low-cost garment products. In the waste stream of a rapidly motorizing economy, old tires are a type of waste that is difficult to make disappear. They are bulky, elastic, and hard to decompose. If left outdoors, they hold rainwater, breed mosquitoes, take up space, and can smolder, releasing thick toxic smoke. Therefore, instead of leaving dead rubber in scrap yards, some facilities in India put old tires through the pyrolysis process. Tires are collected from garages, parking lots, tire replacement centers, and transport companies. When they arrive at the factory, they are inspected, large impurities are removed, easily handled metal parts are separated, and then the tires are loaded in batches into a sealed reactor. When the reactor door is closed, the heating process begins in an oxygen-poor environment. This is not direct tire burning, but the use of heat to break down the rubber structure. As the temperature rises, the tires gradually decompose, releasing oil vapor and gas, while leaving behind a carbon-rich solid residue. The vapor is sent through a cooling system to condense into pyrolysis oil. The non-condensable gas is often recovered to help heat the reactor itself. What remains includes steel and carbon black. The steel is separated by magnets, cleaned, and sold back to the metallurgical industry. The carbon powder is ground, screened, and processed into recovered carbon black, which can be used in rubber, plastics, printing ink, or construction materials if it meets the required standards. If old tires are the hard-to-disappear rubber waste of the motorized age, then carbon black is the dark residue left after they are broken down inside pyrolysis furnaces. It moves through smoke, clings to the air, covers walls, enters people's lungs, and becomes part of urban pollution. It can come from industrial emissions, fuel combustion, or carbon-rich waste streams such as old tires. For many cities, it is something to be removed as quickly as possible. But at Carbon Craft Design, what was once seen as a trace of pollution is brought into a completely different process. First, carbon black is recovered from treated waste sources. Because this powder is extremely fine and easily airborne, workers mix it with water to form a thick slurry, helping control dust and spread the color more evenly. The carbon mixture is then blended with cement and mineral materials. The more carbon is added, the darker the tile becomes. What once dirtied the air now becomes the color of a building material. When the mixture reaches the right consistency, it is poured into metal molds and compressed by a hydraulic press. No high-temperature kiln is needed. Pressure replaces fire, forming flat, solid paving tiles with clear edges and unique patterns. After molding, the tiles must be cured with moisture for several days so the cement can bond properly. Each day, the workshop can produce about 200 tiles. The number is small, but the meaning is powerful. Carbon no longer drifts through the air, but is locked inside a hard surface for floors and walls. But after all these processes, one question cannot be ignored. Is recycling always good? The answer is not as simple as the green color on packaging. Recycling only truly matters when it reduces environmental pressure, protects people, and creates materials that can be used safely. Without those conditions, waste does not disappear. It only moves somewhere else. A biodegradable product may sound clean, but if it ends up in an oxygen-poor landfill, it is still trapped in the wrong waste system. Plastic can be used in road surfaces, but poor sorting, wrong mixing temperatures, or unsuitable materials can turn that road into a hidden landfill instead of an infrastructure solution. Old tires can be pyrolyzed into oil, gas, and carbon black. But if the reactor leaks or emissions are not controlled, the recycling process can create a new layer of pollution. A good recycling model needs more than a clever idea. It requires waste sorting at the source, safe equipment, emissions and wastewater control, a real market for recycled materials, and regulations that make companies responsible until the end of a product's life cycle. Without those things, recycling can become a green cover over a system that remains dirty inside. But if done properly, it can change how a country sees waste, not as something to hide, but as a material stream that must be managed seriously, transparently, and fairly. From the narrow alleyways of Dharavi to the industrial zones on the edges of cities, India is turning waste into a major test for the future of sustainable development. There are things that were once thrown away no longer remain still in landfills, but quietly return to everyday life in new forms within the production machine that keeps running each day. But this is not a simple green story. Behind every cycle of recycling are hard labor, the cost of technology, the risk of pollution, and the immense pressure of a country with more than 1 billion people. If you enjoy stories about technology and engineering like this, please hit like and follow Mandarin Tech.